Hello, I'm Tim Gallagher. I'm the head of the School of Chemistry at the University of Bristol. Bristol Chemistry is one of the larger chemistry departments within the UK, and we draw our undergraduate students from within the UK itself, but also very internationally. What I want to do today is to show you a product called LabSkills, which is a suite of content that is aimed to support the practical experience that students have in the laboratory. These are students at high school, and LabSkills is designed to support A-level, but high school chemistry generally. It also supports foundation-level chemistry at university, and we use the same concepts and the same techniques that are developed within LabSkills in terms of delivering our own undergraduate laboratory experience at Bristol. The distillation equipment has been set up by an inexperienced scientist. Run the experiment to see if there are any problems. So I can see the apparatus. I can then click the Run Experiment button to see what happens. And you can see that my orangey solution is now bubbling. It's bumped. And my glassware has fallen apart. There's clearly something very wrong with the distillation. The technique isn't going to work, and it's not going to give me a good product. It's also going to be very dangerous. So the text tells me there's obviously something wrong here. Well, I think we can all guess that. But it then takes me through a process which allows me to correct the problems. So can we set up the equipment correctly? So LabSkills then gives the student the opportunity to recognize the issues that might or might not be involved in running a distillation correctly. Well, the first thing I can tell you is that the flask that I'm using over here is far too full. It's the same as the problem when you heat something on the stove. If it's too full, it will boil over. So I want to replace my full flask with something that is less full, so perhaps half full. You saw that the glassware fell apart. My receiver flask, my condenser fell apart. So I have two retaining clips here, and I'm going to use these onto the apparatus to make sure that the flask and the receiver stay in one piece. But you'll also remember that the condenser fell apart. I've got another clamp here, so I can attach that clamp to my stand, and that holds all my apparatus together. So I can try. That's a pretty good start. I can try and see what happens. So I run the experiment. I'm boiling. Oh, it's bumped again. The apparatus hasn't fallen apart, but it's bumped over. I haven't done a purification by distillation. So the little red flashing button tells me now if I boil too vigorously, mixed fractions containing impurities can boil over into the collection flask. So I'm obviously boiling it too fast, which probably suggests, if I click continue, that I need to reduce the heat here. I don't want to heat it too hard. The other thing it did was it bumped, and the solution came over in a large mass. So what I might now decide to do is to use these. These are anti-bumping granules. So if I add some anti-bumping granules, you can see them now in the bottom of the flask, they will allow for a much smoother boil and more controlled distillation. Well, I think everybody else will have also spotted that I haven't got any water going through my condenser. So perhaps I should turn the water on. And the other thing that's important here, of course, is where the water goes in and where the water comes out. And I know I want to swap those two over so that when water goes in at the bottom, it fills up the condenser, it drives any airlock out, and I get a more efficient cooling jacket. Okay, so that looks pretty good. Let's try that. So I can see water going through the condenser. I've got a much smoother boil. I've got a vapor going over, and I'm collecting colorless distillate, but I've still got a problem. And the problem here is in order to measure the temperature of the condensing vapor, the bulb of the thermometer should just be below the entrance to the condenser. Okay, well that's going to make the distillation more efficient in terms of the purity of the material, so why don't I just move that up to there? I'm not heating it too much. I've got water going in and out in the right place. I've got my anti-bumping granules. Water jacket's on. The vapor is going up. My thermometer's recording the temperature of the vapor as I'm collecting it. And I'm getting a few drops per second of a nice, clear, colorless distillate. Now if I go into the laboratory, I know how to set up a distillation. I know how to carry out a distillation. I'm aware of what the risks might be in terms of the hazards that this could present to me and also the efficiency with which I could carry out the process. And if I was to go into the laboratory now, I think I would have, and I think every high school student certainly would have the confidence to deliver an effective distillation.